everybody, welcome back to another episode of Maths. We are back in the world here where we were last time talking about different Minecraft block heights. We were talking about pixels, how fractions help us look at that, and yeah, we did a bunch of interesting stuff. And you guys enjoyed that video clearly because it's definitely the best I've done on this channel so far for views and whatnot. So thank you very much for all the interaction, all the engagement, and I'm glad that my audience has gotten something out of it. So without further ado, we are going to practice that a little bit because, like all things in math, you got to get practice in order to master it. So I prepared a few interesting questions, and yeah, let's look at them now. Alright, so I've got the questions right here. So as always, pause the video, try the questions out for yourself. In terms of like remembering the block heights, I'd recommend going into the description to check out the website that I used for reference for these heights, and you can use that for reference for these problems as well. I will also briefly show on the screen the actual image that I used to refer to in case you don't want to actually go into the website. So there it is right there. So yeah, once again, pause it, get a picture of the image, and then try these out for yourself, and let's go through them together now. Alright, so this says the maximum height a player can auto step up is 0.6 of a block. What's the shortest size block you can auto step up from onto a full block? How about onto an end portal frame? Okay, so let's look at the first part. So basically, if we have a full block here, so that is a height of 1, the player, they can't step onto that, right? They will run right into it, so they need another block right here so that they can kind of auto step onto it. And what it's saying is that the maximum height that they're able to actually auto step up is 0.6. So what that means is that this height right here, that has to be 0.6. So essentially we're looking for a block whose height is going to be 0.6 from a full block. So that's basically just doing 1 minus 0.6 or 0.4. So we're looking at a block whose height is going to be 0.4 or higher. Anything larger than that, right, will make this 0.6 even smaller and we'll be able to auto step onto it, right? So for example, a half slab, we know a half slab's height is 0.5, right, a half. So we are able to auto step up from a half slab onto the full block because the difference between this height of 1 and this height of a half, that difference there is 0.5. So we are just looking for basically the minimum, the smallest size of block that we can actually use. It's not necessarily going to be 0.4 because there's not actually any blocks that are 0.4, so we got to find the next largest thing up. So referring to our list here, we can see that the smallest height that's bigger than 0.4 is going to be 0.4375. So that's going to include things like campfires, turtle eggs, and amethyst clusters. And we can even verify some of that in the game. Alright, so we go to our 0.4375 or our 7 pixels tall section, and if we take a full-size block, we see that, yeah, we can auto-step right from this onto the full-size block, no problem, right? We can try these sea pickles, yeah, we can auto-step up onto that. And let's also do the amethyst cluster. It's the same height, right? So we can just auto step right onto it. But if we go anything less than 0.4, right? So 0.375, that means our block is going to be bigger than 0.6 from this height of 1 here, right? If this is 0.375, then the remaining height here is going to be 0.625, right? So it's going to be too large of a height, and we will not be able to auto step up onto it, right? I'm holding forward here, but I am not going onto the block. Alright, and the second part of the question asks, what about an end portal frame? So an end portal frame, that is a little bit smaller than a full block. We can check the chart to see how tall it is exactly. And it looks like we're looking at 13/16 of a block. So here I've got 13/16. And we want to get a block such that this height here is still going to be 0.6. So since that's a decimal, it might be easier to use the decimal version of 13/16. Which is 0.8125. And so if this height here is to be 0.6 from this block to that one, then that means the minimum height of this block here is going to have to be 0.8125 minus 0.6, right? Just like what we did up there. So if we subtract that, we get 0.2125. So that is our maximum block height. But we need to find out what's actually the smallest height that's bigger than this value because there isn't necessarily any blocks that are 0.2125 blocks tall. All right, so our magic number is 0.2125. So It looks like it's going to be somewhere in between these two, right? Because 0.2125 is bigger than that, but it's smaller than this. So it looks like a quarter of a block is when we can start getting blocks tall enough that will give us a half step up onto an end portal frame. So let's verify that. So I'll grab an end portal frame right here. And let's go to a block that is a quarter of a block tall, 0.25. So the easiest to use will probably be this medium amethyst bud. All right, so let's try and auto step up onto it. And yep, we're good to go onto this end portal frame. But if we do anything smaller, so this is just one smaller, so that's the next height of 0.1875 or 3/16 of a block, we're not able to step up onto it. So it looks like we did our calculation correctly. This category right here of the quarter of a tall block is the smallest that we can go and still be able to auto step up onto the end portal frame. All right, so this says when a bell is hanging from the bottom of a block without counting, so before you go into the game and actually count it, how can we figure out how many pixels are in the wooden part? Okay, so just to clarify, we have a block here, and on the bottom of it, we have a bell hanging. And then we've got the actual bell itself. And the bell is a little bit off of the ground, right? So this would be kind of our next block here. So we're looking at kind of this single block space here. So we want to figure out the height of this wooden part, but that's not in the chart. But what is in the chart is the height of the suspended bell here. So let's see if we can use that to figure out the height of this wooden part. So let's go to the chart. And if you look in the 13/16 row, you'll see where it says center part of a single wall, double wall, or ceiling bell. So this is an example of a ceiling bell because it's hanging from the roof of a block, or it's hanging from the bottom of another block. And it's saying that that is 13/16 or 13 pixels tall. So if we return to this bell here, okay, we will see that from the bottom of the block here to the top of the bell, it's saying that that is 13/16. So this height right here is 13 pixels tall. But since in a whole block, right, a whole block is 1, which is 16 out of 16, right, that's an equivalent fraction to 1, we're saying that a whole block is going to be 16 pixels tall. So in which case we can just do 16/16 minus 13/16 because we just want to look at these pixels here, so we're removing the pixels of the bell to the ground. And that's going to leave us with 3/16 or 3 pixels. So the height of this wooden part then we should expect to be 3 pixels. Now let's actually go into the game and verify this. All right, so we're over here at the bell, and as we can see, it is in the 13/16 pixels. So from the top of this yellow concrete to the top of the bell there, it's 13 pixels tall. And our math said that the wooden part should be 3 pixels. So let's count it. All right, I'm seeing 1, 2, 3 pixels. Yep, so we were right. The wooden part is 3 pixels tall, and we used a little bit of fraction subtraction in order to figure that out, and we didn't even have to count it. But we also did for the verification. Let's go to question 3. All right, so next up we've got question 3 here that says how many pixels off the ground is a hanging lantern? Okay, so normally a lantern, if it's put on top of a block, just like so, it's going to have a certain height to it, which we'll check with the chart in a second. But we can also hang the lantern from a block. And that lantern will be suspended slightly above the ground, right? It's a little higher than this lantern here because it's actually hanging from above, right? And we want to figure out actually what is this height right here? That's what the question is asking. Okay, so how can we figure this out? If you recall, the heights that we had told us how tall the lantern was off of the ground, and it also told us how tall the lantern was when it was hanging. So how can we use this to figure out the space in between here? Well, these lanterns, it's the same lantern, right? They're both the same size as each other. So if this height here of this lantern is this height right there, then what we can do is we can take the number that we get for the height of this lantern here, and subtract it from the number we get for the height of this lantern here, because essentially we're taking this height from the bottom of the block to the top of the lantern, and we're removing the height of the lantern, right, by subtracting this height right there. And by removing that height, we're just going to be left with this bottom part right there. So I hope you can see that. We're just going to be left with the basically airspace between the ground and the bottom of the hanging lantern. So let's go check out the values and see what we get. So in the 9/16 column, it's looking like the top part of a non-hanging lantern is going to be, 9/16, right? So that's our first number. And then if we go up to the 5/8 column, which is the same as 10/16, we get the top part of a hanging lantern. Okay, so the top part of the non-hanging lantern, so the distance from the ground up to here, was 9/16. And the distance from the ground up to the top of the hanging lantern was 5/8, which is the same thing as 10/16, right? If we multiply the numerator and denominator by 2 each. So if we take the difference here, 10/16 minus 9/16, we get 1/16, or 1 pixel. So it looks like the hanging lantern is only going to be 1 pixel off of the ground. Let's verify this. All right, so I'm at these hanging lanterns here, and we can't really see the bottom of them, so I'm going to break this block here. And to line myself up better to be able to see this, I'm going to go a little bit below here. All right, so cake looks like it's going to give us a pretty good look. So we can see it's slightly off the ground. And if I place a carpet, because remember, a carpet, that was 1 pixel tall, right? 1/16, right? So 1 pixel tall. So if I place a carpet next to this, we should expect them to basically occupy the same pixel space, both the carpet and the space underneath this hanging lantern. So if I place some carpets around here, we see that, yeah, it looks like, even though I'm not perfectly lined up here, it looks like the height of the carpet is the same as the height underneath this hanging lantern here, so we did our math correctly. All right, so question 4 is a pretty interesting one in my opinion. It says when a pitcher pod is first planted on farmland, so this is like its immature state, it's 3/16 of a block. However, when you count the pixels of its base, you count 4 pixels. Why is this? So let's actually, first of all, verify to show what I'm talking about. Okay, so the question is talking about this pitcher pod when it's first planted, just like here. And it's in the 3/16 row, so yeah, it's 3/16 of a block tall. And that would mean we would expect it to be 3 pixels. However, when we count, just like the question says, we get 1, 2, 3, 4 pixels. So the question's asking, why is this the case? Okay, so we've got our farmland here, and we are planting a little pod on top of it. And this height here is 3/16. However, it's made of 4 pixels, so we want to figure out why that's the case. So just to do some investigation, let's look at the height chart. All right, so if we look at the height chart and we look at the 3/16 column, we see an age 0 pitcher plant. So that is what we have. However, it is planted on farmland. So let's check farmland. Farmland is 15/16 of a block. So it's not actually a full block. All right, so farmland isn't a full block, and this is going to be the key. So this height here is 15/16. And this 3/16, that's 3/16 off of the ground, off of a single block, right? So if I have a full block height here for reference, then the pitcher pod, that 3/16 is going to be this 3/16 kind of above the block here, right? But the farmland, that is 1/16 below the block, right? Because it's 15/16 tall. That leaves an extra pixel of space in between here, right? If this is 3/16 above the block, this is 15/16, which makes it 1 below the block, we have 1 extra pixel of space to work with in here. And that's the 4th pixel of the pitcher pod plant. Its hitbox actually extends downwards into the block below it, which is an interesting property because no other block in the game actually does this. All right, so let's look. Yeah, we've got the 4 pixels, but notice where it starts is one kind of sunk into the ground here, right? The top of these 1 high blocks is 1 pixel above where this farmland is, right? So that 4th pixel of this, these 3 pixels are what actually account for the height of 3 here, but the 4th pixel, that is actually just what's connecting it to the farmland below this height of 1 block here. And these other maturity states of a pitcher plant, it's the same kind of deal. So these are in the 5/16 row, so they are 5 pixels tall. However, when we count, we get 1, 2, 3, 4, 5, 6 pixels. Just like that maturity stage over there, it's 1 more pixel than it is the height, and that's because it's sunk down by 1 pixel because of this farmland here. Let's move on to the very last question. All right, numero cinco. So this is how many blocks off the ground will you be if you stand on 20 layers of snow? How about 25 layers? So let's start with 20 layers. So recall, 1 layer of snow, that is basically doesn't have a collision box. You just walk right through it, you have a height of 0. So that's for 1 layer. So 1 layer, you have a height of 0, but its appearance That's a height of 1/8. So it's 2 pixels tall visually, but when you walk through it, it doesn't actually raise the player up at all. So that's its height, that's its appearance, and that's its layer. If we do 2 layers, right, that's going to raise the height up to basically the height of what one of them looks like. So it raises the height to 1/8, but it looks like it's 2/8 or a quarter of a block tall. And this is just going to continue on. Eventually, we're going to hit 8 pieces. Okay, so I've crammed 8 pieces into there. And its height, once again, it's always going to be 1 less in the numerator, so this is 7/8, but visually it looks like 8/8 or a full block, so it appears like it's 1 block, right? But then this is where the bug happened. So if we write this out again, so if we look at the 9th layer, its appearance is basically 1 1/8 or 9/8, right? So the numerator here is counting how many layers we have. So it looks like, yeah, we've got 9 layers there. And we would expect it to be 1 less, so we would expect the height to be 1. However, we saw that the bug with this is that it actually was still calculating what was below, so it's still calculating 7/8. If you want more information on that, please go back and watch the video. But we see that we get a height of 7/8 when we're at 9 layers. So to express 9 layers, we'll just say that this full block here is the 8/8, right, from here, and then this is our extra layer on top, just so it doesn't get too crammed. And we can keep on going. But once we get to 16 layers, so that's going to be an appearance of basically 2 blocks, right? Since we're going to be at 16/8, which is 2. So our appearance will be 2 blocks tall. However, our height, just like before, is going to be 15/8 or 1 7/8 of a block. But now we just have to get up to 20 layers. So we're going to have 17, 18, 19, and 20. But for all of these blocks in between, it's really just the starter one where it's kind of weird, where it just kind of copies the state of the previous amount of layers. But for all these in between, it's just going to be a height of 1 less than the appearance of snow layers. So here, our height is going to be essentially just 1 less than 20, or 19/8. So we get a height of 19/8, despite it looking like 20/8 of a block tall. So we would expect then to be 19/8, which is the same thing as 2 and 3/8, right? We can convert 19/8 into a mixed number by doing this division, and we use the remainder for the numerator of the mixed number. So we have 2 and 3/8 is going to be the height of the block. All right, so I'm over where we did the snow demonstration from last time, and we're looking at 20 layers. So let's just count up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so there's 20 layers there, and we expected that to be 2 and 3/8. So 3/8 should be 0.375. Just refer to our manual here. Yeah, 0.375 is the same as 3/8. So when we go on top of this, we should expect a height of 2 and 3/8, or 2.375. And that's exactly what we get. So we were correct in our calculation of these 20 snow layers. So let's find it for 25. All right, so we've gone up to 20, and I should have drawn in there, but 20 is somewhere inside of here. And we will be going up to the next multiple of 8 in this row, which will be 24, right? 8, 16, then 24. So we can kind of think of, I'm just splitting up these rows into rows with 8 kind of sets of layers in them. So I'll just make kind of a dividing line here. So we're looking at 24, which visually, that's 3 blocks tall, right? 24 divided by 8 is indeed 3, so we would get 3 blocks tall. But once again, the height is going to be 1 less than the appearance, so this will look like 23/8. So this will be 23/8 blocks tall, and its appearance is going to be basically 1 taller than that, right? That's going to be basically the 3 blocks, or the 24/8, that we actually see right there. But now we can get up to 25, right? So 25 is just 1 more than these full 3 blocks. But remember, this is where the bug occurs, where once we get to the appearance of a full block with the snow layers, adding 1 more after it doesn't change the height, right? Because it's calculating the height of the block below it when we're adding a snow layer onto kind of this new block. But the height of the block below it is still being 23/8, so it's calculating that height still to be 23/8. So we would expect then our height to be 23 over 8, which is equivalent to, if we make this into a mixed number, which is equivalent to 2 and 7/8 of a block, which as a decimal should be 2.875. Alright, so we still have the 28 layers of snow here. Let's just add 5 more. 1, 2, 3, 4, 5. Stand on top of it. We're expecting 2.875 to be our height. And that's exactly what we get, right? So the one layer of snow that we add between 24 and 25, that changes nothing. All right, well, that is going to be all of the problems for today. I hope you're feeling more comfortable with these concepts, and I hope you had some fun trying out these Minecraft math puzzles or problems or whatever you want to call them. And this is going to wrap up our third section on the fundamentals of algebra. We've really come a long way. I still have some more sections for fractions, so we are not done our journey with fractions yet. But I hope you're having fun. I'm enjoying myself. And because it's the last video in this kind of section, we will be having a checkpoint video next. So that's going to test your skills over these last several videos. So that's going to cover everything from where we started fractions. So that is fundamentals of algebra number 23 all the way up to the current one, which is 34. So go back, review some concepts, try some exercises, and I will see you in the checkpoint. But until then, you have a good one. You stay groovy. I'll see you in that next episode.